Apophis, one of the most potentially hazardous asteroids ever discovered, is coming for a visit. In 2029, it will approach our planet at a distance of just 32,000 kilometers, or about 19,900 miles, passing below the orbits of geostationary satellites and shining as brightly as a satellite itself. This event will make it visible to billions of naked-eye observers worldwide, a rare occurrence that occurs only once every few thousand years. Even more exciting is that a NASA mission is already on its way to study the asteroid up close. However, one might wonder why ground-based observations alone are insufficient for studying this asteroid, or why we are sending a spacecraft to investigate a celestial body that was once considered the most dangerous asteroid. Finally, and most importantly, is there cause for concern? Resembling a peanut shell in shape, Apophis was first discovered in 2004 when astronomers located it approximately 170 million kilometers from Earth. Initially designated as 2004 MN4, this 340-meter-wide rock didn't seem noteworthy. However, as subsequent analysis indicated a 1 in 37 chance of it colliding with Earth in 2029, it captured widespread attention. A 1 in 37 probability was the highest ever calculated for a significant asteroid impact in recorded history. This is when the asteroid earned its name Apophis, after the Egyptian god of destruction, and became known as the most dangerous asteroid ever discovered. In March 2021, Apophis conducted a distant flyby of Earth, allowing astronomers to utilize powerful radar observations to refine its orbit around the Sun precisely. To the relief of everyone concerned, the updated analysis definitively ruled out any significant Earth impact events for the next century. However, there is a factor that cannot be ignored, known as the Yarkovsky effect, which arises from the interaction between the asteroid and solar radiation. When sunlight strikes a rotating asteroid, the day side heats up. As the asteroid turns, the night side cools down and releases the heat. This exerts a small thrust on the asteroid, which can change its direction over time. The Yarkovsky effect is challenging to model, but it can make a big difference in determining where asteroids end up. Because we don't know exactly how the Yarkovsky effect will perturb Apophis's orbit, we have limited knowledge of where it will be as it approaches Earth in the coming years. Scientists thus have to consider a range of possible trajectories, depending on how strongly the Yarkovsky effect is pushing on Apophis. A few of these trajectories line up with regions of space called gravitational keyholes. If Apophis were to pass through a keyhole, Earth's gravity would bend its path in just the right way to cause an impact on a subsequent orbit. Astronomers have been keeping an eye on the trajectory of Apophis since its discovery. Ground-based observations and radar measurements indicate that the asteroid is slowly deviating from a purely gravitational orbit. If this trend continues, the possibility of an impact scenario in 2068 cannot be entirely dismissed. In other words, there remains a slight chance that this massive asteroid may collide with our planet in the next 50 years. The Yarkovsky effect is influenced by changes in an object's temperature due to radiation exposure, asteroid composition, and stellar wind, among others. This means we can only arrive at concrete conclusions if close and multiple observations are made. And this is where NASA's OSIRIS-APEX mission comes into the picture to fill in the gaps. The OSIRIS-APEX is the same spacecraft that was launched in 2016 under the name OSIRIS-REx to collect samples from the asteroid Bennu. On October 20, 2020, it successfully touched down on Bennu's surface, gathered a sample, and later brought it back to Earth on September 24, 2023. The spacecraft released a capsule containing fragments of Bennu into Earth's atmosphere, and this capsule then descended via parachute, landing in Utah, where the mission team eagerly awaited to recover the samples. The Bennu sample is the largest asteroid sample ever that has been brought back to Earth. However, the journey for the spacecraft continued. Just 20 minutes after releasing the capsule containing the Bennu sample, the spacecraft fired its thrusters, beginning a new mission, which we now refer to as OSIRIS-APEX. Currently, it is en route to rendezvous with Apophis. More specifically, OSIRIS APEX stands for Origins, Spectral Interpretation, Resource Identification, and Security, Apophis Explorer. Just 1 hour after Apophis completes its close approach to Earth on April 13, 2029, OSIRIS APEX will utilize Earth's gravity to enter an orbit around the asteroid. It will conduct an in-depth study of Apophis for 18 months, collecting valuable data. Unlike the case of Bennu, OSIRIS APEX won't be able to collect a sample from Apophis. However, it will approach the asteroid's surface and employ its thrusters to execute a maneuver designed to expose Apophis's subsurface, enabling researchers to gain insights into its physical and chemical composition. Over 1.5 years, OSIRIS APEX will extensively map the asteroid's surface. This will allow mission scientists to examine any notable changes brought about by Apophis's brief interaction with Earth's gravitational influence. Even though tidal forces are relatively small, they can still trigger minor landslides and uncover fresh material for study on the asteroid's surface. Additionally, the spacecraft will precisely determine the asteroid's orbital motion down to the meter scale. This enhanced precision will enable researchers to predict Apophis's future trajectory accurately. Currently, predictions extend only until 2116, but OSIRIS APEX's measurements are expected to extend this forecast horizon significantly. That said, OSIRIS APEX is not the sole spacecraft set to visit Apophis. Several missions are also targeting the asteroid. Missions featuring smaller spacecraft, such as Apophis Pathfinder, are scheduled for launch in 2025-2026. This spacecraft will execute the first-ever close flyby of Apophis, reaching the asteroid within approximately 1 year of its launch. Furthermore, earlier this year, NASA officials presented a proposal at the 8th Planetary Defense Conference to dispatch a swarm of tiny spacecraft to investigate Apophis. A detailed study of Apophis will surely pave the way to better understanding several dangerous asteroids lurking around us. These missions will act as a phenomenal step forward in advancing our knowledge of the behavior of Apophis, thereby guiding us to develop effective defense mechanisms against such strikes. Before wrapping up this video, I want you to think about something. How often have you wondered about the stars, the vastness of space, and our place in this universe? It's fascinating.